Introduction to Geographic Information Systems. What is GIS? Definition: Geographic Information System, GIS, is a computer-based tool that allows users to create, manage, analyze, and visualize geographically referenced information. Components of GIS: hardware, physical devices like computers, GPS units, and servers. Software: GIS software, e.g., ArcGIS, QGIS, used to process and analyze spatial data. Data: geospatial data that includes both spatial, location-based, and attribute, descriptive information. People: the users who manage and analyze the data. Methods: the techniques and procedures used for analyzing the data. History of GIS. Early developments. GIS has its roots in cartography and mapping. The Canadian GIS, CGIS, developed in the 1960s by Dr. Roger Tomlinson, is considered the first true GIS. The development of computer technology in the 1970s and 1980s significantly advanced GIS capabilities. Evolution of GIS: transition from mainframe to desktop computing in the 1980s. The 1990s saw the rise of commercial GIS software. The Internet and mobile technology in the 2000s expanded GIS applications. Components of GIS: data input, the process of collecting and entering data into the GIS. This can include digitizing, converting paper maps into digital format; scanning, creating digital images of maps; remote sensing, collecting data from satellites or aerial imagery; field surveys, using GPS and other tools to collect spatial data on the ground. Data storage and management. Spatial data represents the location, shape, and relationship between geographic features. Attribute data describes the characteristics of spatial data. Database management systems, DBMS, used to store and manage large amounts of data. Data manipulation and analysis. Spatial analysis, techniques used to examine the locations, attributes, and relationships of features in spatial data. Overlay analysis, combining multiple layers of data to analyze relationships between them. Buffering, creating zones around features to analyze proximity. Data output. Maps, the most common form of GIS output, used for visualizing spatial data. Reports, summaries and analyses of spatial data. Graphs, visual representations of data relationships. Applications of GIS: environmental management, monitoring natural resources, managing wildlife habitats, and analyzing environmental impacts. Urban planning, zoning, land use planning, and infrastructure development. Transportation, route planning, traffic management, and logistics. Health, tracking disease outbreaks, planning healthcare services, and analyzing health data. Disaster management, analyzing hazard risks, planning evacuation routes, and managing emergency responses. Future trends in GIS. Web GIS, the use of internet platforms to share and analyze geospatial data, i.e. dashboard, web apps, etc. Mobile GIS, GIS applications for mobile devices, enabling field data collection and analysis. Cloud GIS, storing and processing GIS data in the cloud, allowing for greater collaboration and data sharing, i.e. Google Earth Engine. Big data and GIS, integrating large datasets with GIS for more complex analyses. Real-time GIS, analyzing and visualizing data as it is collected, often used in monitoring and tracking systems, i.e. location tracking using Google Map. Important concepts to remember: geospatial data, data that is associated with a specific location on the Earth. Vector data model, represents features as points, lines, and polygons, e.g., cities, rivers, and boundaries. Raster data model, represents data as a grid of cells, often used for continuous data like elevation or temperature. Coordinate systems, systems used to define the location of geographic features, e.g., latitude and longitude. Projection, the method of representing the curved surface of the Earth on a flat map. Study tips. Understand the basics. Make sure you grasp the fundamental concepts such as what GIS is, its components, and its applications. Visualize data models. Try to visualize how vector and raster data are used in GIS. Practice with software. If possible, use GIS software like ArcGIS or QGIS to explore the concepts practically. Stay updated. GIS is a rapidly evolving field, so keep an eye on new trends and technologies.